rationalizing and simplifying radicals. Okay, need some help with that? Let's work on it. So let's get it. Here it comes. To rationalize means it's a process to get a square root or get a root out of a denominator. Depending on what the problem looks like, we go about it different ways. If there is a monomial, a single root in the bottom, we're just going to multiply it by itself. And if I multiply the bottom of a fraction by root 3, I would need to multiply the top of the fraction by root 3. And multiplying by root 3 over root 3, that's just a fancy form of 1. That's why I'm allowed to do this. So now I have 2 times root 3 is just 2 root 3. Root 3 times root 3 is root 9, or root 9. And the square root of 9 is just 3. So notice, there is no more square root in our problem. On B, this is a cube root of 2. We get a little sneakier here. The first cube root I know, 1 times 1 times 1 is 1. But the next one would be 2 times 2 times 2 is 8. How could I turn this into an 8? Well, I would need to multiply by the cube root of 4 on top and bottom. Again, so that's just a fancy form of 1. That's why I'm allowed to do this. And now 2 times the cube root of 4 is just 2 times the cube root of 4. But on bottom, the cube root of 2 times the cube root of 4 is the cube root of 2. And the cube root of 8 is simply 2. Now I have a times 2 on top. That will cancel with my 2 on bottom. My final answer is just the cube root of 4. Tricky. Mathematically speaking, rationalizing a numerator makes it unsimplified. Like the whole point of this was we don't want square roots in the denominator. But if you rationalize the numerator, that's exactly what you're going to do. That's okay. We will use this. There will be a time in our math lives later this semester where you will need to rationalize a numerator to recognize something that you haven't seen before. So let's do letter D. I want to rationalize this numerator. So just as before, I'm going to multiply the top and bottom by just the radical part and say, okay, I have radical 8 times radical 8. That would be radical root 64. And square root of 64 is just, I'm going to have 4 times 8 on top. On bottom, I'm going to have 3 times the square root of 8. Can we stop playing this game? The square root of 8 is 2 times the square root of 2. We can talk about why that is if you need to. But we can start to clean stuff up here. I have a 4 over a 2. It's just a 2. 2 times 8 is 16. On bottom, 3 times root 2. And that has been rationalized. I rationalized the numerator, and then I simplify. Okay? Let's talk E. E, we cannot just multiply by root 3 over root 3. If you tried multiplying by root 3 on top and bottom and distributing, you would still have a square root in the denominator. So we need to, on this one, multiply by what we call the conjugate. And the conjugate of 1 plus the square root of 3 is 1 minus the square root of 3. I still have to multiply by a fancy form of 1. Right? This is anything over itself is 1. But by multiplying by the conjugate down here, you're going to see that square roots go away. So let's look at it. To FOIL this, 1 times 1, 1. 1 times negative root 3, negative root 3. Positive root 3 times 1, positive root 3. And a positive root 3 times a negative root 3, that's just negative 3. Okay. So on top, I'll have my distributive property. That's easy, 1 minus the square root of 3. But now on bottom, notice a positive square root of 3 and a negative square root of 3. That's terrible handwriting. Okay, cancel. And I'm left with 1 minus 3 is negative 2. On top, I have 1 minus square root of 3. That's an okay answer. We don't usually like to have negatives in our denominator, so instead I'm going to put that negative in the numerator on both of them, but negative 1 plus square root of 3. That's good. Okay. I think I'll let you guys do the rest. Bring your questions to me, but we definitely need to know how to rationalize denominators. Peace.